Hello, I'm Dr. David Kordowitz and welcome to Programming. Today we're going to be talking about object-oriented programming, which is a technique that allows us to modularize our code, which has become popular in programming since about the 1980s or 1990s. Let's begin. So far, everything we have done has been procedural. In other words, you follow a flowchart type diagram and you work your way through your given program. This makes sense when we have things like repetitive tasks and other ways that we kind of go through a process. So think about a cookbook. This is sort of how procedural programming works. You have a bunch of steps, you follow the steps, and you get to the result. The catch is that procedural programming looks at everything the same way. So basically we have our steps, we follow our steps, and we get to the answer, but we don't really care about the data that we're moving around, and there's no special way to handle different types of data. So there's no real flexibility here if you want to do something different, such as working with specific types of data and having different treatment for different types of data. So in the late 80s and early 90s, the idea of object-oriented programming came out and became popular. So what I want you to think about with object-oriented programming is the idea of what things actually are. So for example, a fir is a type of tree. So we can categorize things based on what they are. And in OOP, we're going to use what we call classes, and those classes are going to be what we call instantiated, or copies of them created, that are going to be our objects. So everything is going to happen within these objects, which allows us to individualize code based on what things are. Now, it's important to also realize that certain languages have added OOP as an after effect. So this is the primary difference between C and C++, is that C++ can be object-oriented, where C has no facilities to do that. So let's think about a real-world object, and we're going to think about an elevator. So I want you to take a moment and think about an elevator. I know most of you probably, that's kind of a mundane thing to think about, but this is a real way of sort of capturing what object-oriented programming is. So a question to you is, what is common amongst elevators? So there are millions of elevators around the world. What's common to them? Well, on modern elevators at least, we have buttons. So you push a button, it does something. This isn't true if you're talking about much older elevators, but we're going to kind of ignore those for now. Every elevator is going to have an elevator car of some sort. It could be a box type car, like it's made out of metal. It could be made out of glass. It could be anything, but they all have cars. They also all have some form of light, because you need to be able to see what's going on so you know which button to press and you know where you are. What's not common between different types of elevators? Well, they're all different sizes. Well, that's easy because that's basically a property of the elevator. So when we think about it, we can set a property of an elevator to say this is how big it is. How much does it weigh? That's also a property of it. What direction is it going? Well, some are going up, some are going down. How long is the shaft? How far do we travel? Is this a 5-story building or a 100-story building? Those are going to be different, but in the end, the overall shell of the elevator is exactly the same. So what we have to think about is that is all the same, and the interface is always the same. So if you walk into an elevator in Japan, for example, you'll know how to use it even if you come from the US, because the general idea of how you interface with it is exactly the same. Now, the properties of it may be completely different, but the actual core of an elevator is an elevator. So what we can do is start classifying things this way. So when we think about different designs of things, we can use this general framework to be able to build things for programs. So let's for a moment look at what is a class. And a class is what we call an abstract data type, which means you create it. It contains what we call member variables. In MATLAB, we call these properties. And they have different names in different languages. And then we have what we call methods or member functions. These are functions that can operate on the data which is contained within the class. So in other words, your methods can operate on the properties to provide you with different information and to change things within the properties. Now, example of properties on an elevator would be something like the door. Is it open or closed? What floor is it on? What direction is it going? How big is it? How many floors can it go? Those sort of things. Our methods then will call back to those and do certain things. So, for example, is the door open? You will ask if the door is open, and the class will tell you, yes, it's open, no, it's not. Now, you may have one that's set door to open that tells it to open the door. What's the current floor? What's the travel direction? So these methods are actually functions that you can call that manipulate the individual data or read the individual data. Now, an important concept here is what we call encapsulation. Encapsulation allows us to protect parts of the class, so you can protect some of those properties so that only the class itself can edit it or other classes can edit it. So if we think about it, in encapsulation, we have what we call public methods and public properties, which basically anybody who can touch the class can edit. So in other words, in MATLAB, we could go in and write a program and it can deal with the public members. However, it only can deal with the public members and not the other members, because private members, for example, can only be accessed by members of the class itself. So in other words, if you want to look at, say, a private member, you may need a public method to actually be able to pull that property back out. This is really important because it makes it so that you have to go through the right programming channels to be able to program what's going on inside the class. And you can't just go in and change the value of a variable, for example, on your own. This is good because it prevents there from being collisions and being errors due to multiple things editing the variables. The last type is what we call protected. Now, protected classes or protected methods and protected properties are accessible by classes that come from the same parent or base class. So what the idea is that we're going to talk about is how we can derive new classes from existing classes. This is really actually kind of a neat process, and it allows you to go through your development and not have to write every single thing every single time. This encapsulation method allows classes that are derived from your class to access methods within your class. So let's think about this idea. We have what we call inheritance. So let's take a moment to think about a duck. And a duck is a type of waterfowl. So what do you think of first when you classify a duck? Do you say it's a bird? Is it a waterfowl? What is it? So if we think about the hierarchy, right, we start with a bird, and a waterfowl is a type of bird, and a duck is a type of waterfowl. So we can say that, well, a duck is going to have the general characteristics of a waterfowl. Now, it may be a little different than a standard waterfowl, but it's going to have the general same characteristics. And then a waterfowl is going to have more characteristics than, say, a bird. So it's going to be slightly different, but a bird is the most generic we want to get. Now, if we really wanted to, we could go up one level and say animals, or say, warm-blooded animals. And you can keep going up and being able to inherit information from the previous levels. So when we think about it, this is really useful because we can bring both properties and methods from existing classes that we want to derive from. In MATLAB, we call this subclassing. In a lot of other languages, we're going to call this either derivation or subclassing or class inheritance. Another concept which we have to think about is what we call polymorphism. And the general idea of polymorphism is that we don't really need to instantiate the upper level classes because our class that we have created can contain all the information we need. Therefore, when we create a duck, if it's inherited information from waterfowl and bird, we're kind of agnostic to that. We don't really need to know that a duck is a waterfowl is a bird because it really honestly doesn't matter as far as the compiler and or interpreter is concerned. So we just don't mess with it. We just can call duck, and duck will do everything we need it to do. So let's take a look at a quick example using a deck of cards in MATLAB. We're going to develop the classes as well as the subclasses to be able to get some interesting information out and be able to see how this works. So in MATLAB, classes fall into their own class files, where in some other programming languages this isn't true, such as C and C++. We can use our classes in the same files that we've already been creating. In MATLAB, the first line of a class file is going to be class.def, followed by the name of the class. So for example, let's use card. So it's like a deck of cards. Now, it's important to note that if you want to, you can go to the new menu and create a class right here. However, doing that is going to fill in some of the information you need and may not be applicable to the type of class you're trying to create. So we're going to call a card what we call the base class. So a card is just going to be a card. It's not going to inherit from anywhere. So the first thing we need to do here is include some of our properties. So we're going to type properties to define our properties. And in this case, I want to set my access to these properties to private. The reason being is I don't want anybody from the outside world to be able to change things about my card. So for example, something that we may care about is our suit and our rank. So the rank being the number on the card. So these are examples of some private properties that we want to maintain. So then we can do end to end our properties. Now we need to create some methods to operate on these. So the way we're going to start is a method that we call the constructor. So we're going to do methods. And if we're going to keep it public, we don't really need to worry about telling it that we want the access set to public. So the first thing we want is what's called the constructor. The constructor is called when you first instantiate the class. So it's going to set the card up. So let's say that we're going to call it CD for card is going to be equal to card. And we're not going to take in any properties. So we need to define this as a function. And so we have our CD, which is going to get created. We have our card, which is going to get created. And so we need to say, okay, well, CD dot suit, which is going to tell me the suit of the card is going to be equal to, and we have 4 suits, so basically we have the numbers 0 to 3. So we're going to say 3 times rand, and we're going to say round that. And so what that's going to do is that's going to set our suit to be equal to 3 times a random number. Now for our rank, we have 0 ace through king, which is 13. So here we're going to want to get 13. So we're going to say round of 12 times rand plus 1. And what that's going to do is that's going to shift it from 0 to 12 to 1 to 13, or ace to king, because we don't have any card that's worth 0. We can then type end here to end our function. So now we need to add a method to be able to see what our suit and rank are. To do this, we can simply say, okay, function, and I'm going to return S and R for suit and rank. And we're going to say that this is equal to get card. And then in our function, the first variable we need is going to be our card, because we need a way to be able to edit to have that instantiation of the card present in our function. So we're not going to have to manually feed it that, but we need it to be there anyway so we can use it. Now all we need to do is say that S is equal to CD dot, and it's going to be suit, and that rank is going to be CD dot rank. We're going to end this function, and we're going to end our methods. Now, if we wanted to add something, for example, like a method to adjust the card value, we can now do a private method. And to do that, all we need to do is create a second method section. And we're going to say access equals private. And we can now say function, and we're not going to really return anything, but I'm just going to say, okay, so it's going to be function, it's going to be set card, and the first thing we're going to get is CD. Then we're going to get our suit and our rank. Now, in this case, what we're going to do is we're going to say cd.suit equals S. And so that sets our suit, and cd.rank equals R. Now, we're allowed to do this because this class here is the class that's instantiating. So in other words, we have the individual object here that we're manipulating the items within itself. Now, this function can't be called from the outside world because it is private. Now, the last line here is going to be to end the class def, and let's save this. And you must call it the same thing as the class. So we're going to call it card. Now that this is saved, we can go ahead and run and try this out. So let's go ahead and create another file, and we're going to start with a close all, clear all, CLC. Or better than clear all, let's change this to clear vars. Now what we're going to do is we're going to create a class. So we're going to say our card, CD, is equal to card. Doing this should create an instantiation of the class. And if you notice in my workspace now, and let me drag this over so you can see, I now have a 1x1 card. So now let's get the values. So we're going to say S, R equals CD dot, and if I hit the tab, I get the fact that getCard is the only function I can call, and getCard doesn't take any arguments, so that's going to be it. And let's do display S. Well, we're going to do num, or bracket, num to str of S, and then we're going to add a space here, and then we're going to do num to str of R for our rank. Now we'll close this out and let's run this. So if we run this, we find out that our first card is going to be a 2, which we could say is, for example, diamonds, and it's going to be 12, which is going to tell me that it is the queen of diamonds. We run it again, we get the 3 of hearts or the 3 of spades or whatever you want to assign that class. And we can keep going, and each time we're going to get a different card. Okay, so now let's say we want to change our game, and we want to create an Uno card. Uno has slightly different restrictions. The cards go 0 through 10 instead, and then we have skip and other and wild and things like that. Well, for this purposes, let's say that it just goes 0 through 10 and has a suit or a color. So what we're going to do is we're going to make a new class that we're going to call Uno card. Now we're going to use the less than sign here to tell it that we want to derive this from card. So by doing that, I now have the entirety of that card class contained within this class without writing the first line of code. Now we can keep our methods the same or keep our properties the same, but we need to change our constructor. So to do that, I can just say methods, and I could say Uno card, or UC equals Uno card, and this is going to be obviously a function. And so we're going to say UC equals Uno card. Now all I have to say is, okay, UC dot, and we want the Uno card to be our, we want our our thing to be, our card to be the say the suit. So uc.suit equals, and then we're going to say uc.suit is going to be equal to rand, 10 round of 9 times rand plus 1. Now what I want you to notice here is, really quickly, is that we're going to have an issue. So let's say rank, actually this is going to be our rank, and our suit is going to be equal to round 4 times rand. Now we're going to have an issue here with our encapsulation. And let's save this, and we're going to call it Uno card. And what we're going to do is call it the exact same way that we called our previous card. So instead here, I'm just going to copy this and paste it. And we're going to call this Uno card. And let's change this to UCD instead of CD. And UCD. And when we run this, we get an error. The reason we get the error is, if you remember, in our card, we declared our properties as private. Now, we don't really want to define them as private. Rather, we want to define them as protected, because we want our derived class to be able to modify them. So now if we come here and we run this again, this should run correctly. And now we get 7 in one of our classes 0, which could be blue or red or yellow. So the general idea that we get here is that we can say that an Uno card is a card. So an Uno card is derived from a card, which means we get all of the properties and all of the methods. However, if we set the access to private, we don't have access to those in the derived classes. However, and if we set it to protected, we have access in the derived classes. And then if it's set to public, we have access to it everywhere, including the command line. This concludes the Introduction to Programming for Engineers course. I'd like to thank you for all the time that you've put into these videos, watching them and practicing your skills. I'd like to wish you luck into your future programming endeavors, and thanks again.